Brought to you by Connect.js, Atlanta's premier JavaScript conference. Sponsored in part by FeatherDirect. Need a mobile app? Contact us for your custom mobile solution.
It's these guys. From the left to right, you can actually see the works who work on Node.js core, all the way starting from Ben Nudis and Bert Belder, who between themselves probably write 40% of Node core. And we have guys like Richie Matori, who was the founder of Deployed, Miroslav, if you have used tools in the Node.js ecosystem around debugging, Node Inspector, Miroslav maintains it, and Raymond Fang, who is one of the main architects of Loopback, as well as maintains Express.js. So it's a great all-star team, and between them and the rest of the company, we contribute 50% or more of the Node's core base today. And we recently took over Express maintenance from TJ Halovichuk. So if you're using Express, show of hands, how many guys here use Express? Okay, quite a bit. All right. Before I move on, how many guys are devs here and would like to see some live coding? Okay, cool. And who is entirely new to Node? Who do I need to sell Node to? Okay, that's great. Okay, how many of you guys have a Node application running in production, a real-time production? Okay, that number significantly goes down. Okay. All right, I will find out why, right? So I'm not, what am I here to do, right? I'm here to give you a fresh pair of gloves to pack a punch in Node.js. So a couple of updates before I go in there. Express has been updated. We have been working on the docs and the new website around Express. And you'll see more and more improvements as requirements come in beyond Express 4.0. So let's see for a while what we are trying to solve here, right? Why is that number of people rolling applications to production so low? So here's a pointy-haired architect guy who's saying, let's touch up our SOA stack for mobile applications. And by the way, let's try to bring in Google Glass to work, right? And the developer, you know, you can read what it says, but essentially he says, for all that to work, I need an API. And it's now beyond recognition that those APIs are getting built in Node.js. That's why Node.js is so hot. That's why enterprises are jumping onto Node.js, because everybody's trying to build an omni-channel API, which is lightweight, which talks JSON, is flexible enough, can talk with an Angular app on the front end, a MongoDB at the back end, can translate data in the same format, which is JSON, right? Okay, so the architect guy does some reading and says, okay, I recommend Node.js for the API strategy. And the boss is sure to shoot it down. He says, Node is nerdy. Are you sure your developers know what's cooking, right? It's a new tech. Well, it's not really a new tech, right? JavaScript has been around for 10 years or so. So Node.js, believe me or not, how do you convince that, tell that story, right? Node.js actually has an application lifecycle. And you start all the way from composition of an API to going and deploy and scaling it, to monitoring it, and finally managing and securing those APIs. As you move from left to right across your development to production lifecycle. So let's start with debugging, right? Show of hands, anybody's used Node Inspector? Quite a few, okay. So this came out of a project maintained by Danny Coates at Mozilla. And we took over maintenance of this today, and we have baked it into a pretty solid debugger, which runs out of container. Doesn't really need an IDE. Has great features like live edit. You can actually change code on the browser and persist it back to the server, all because JavaScript is running isomorphically on the browser itself. So let me show you a couple of tricks with Node Inspector. So I'm going to open a terminal window here. You said coding, you're going to get coding. So is this legible? Oops, sorry. I should have turned on my metering. Okay, is this legible from the back? Okay, so how do you debug a running application, right? So let's say I have a sample application, and this is an Express.js application. The way I debug this is saying, hey, just do SLC debug. So when we load SLC, a strong loop controller layer, what we ended up doing is chained a lot of open source tools underneath for you to make life easier in production runtime, right? That's one of the missing pieces. There's almost a choice of too many. What do you use, right? What can you bake into a full control chain out here? So if I just do SLC debug, what it does is opens up a Chrome window, directly takes me to a breakpoint where I was running my code. And this is integrated with unit test frameworks like Mocha. Now, if I wanted to run this piece of code and look at call stacks, and look at all my scope variables here, let me prop this bigger. Let me try to make this browser smaller a bit. Okay, this might be better. So you can actually see that this is paused on a JavaScript breakpoint. Now, if I look into my scope variables, I can look into each of the constructor. I can go into any module, any protocol. I can see what pieces of objects or arguments are defined in there. So this is classic, debugging without an IDE. But guess what? This is running in the Chrome browser. Why? Because this is built in with the Chrome's development toolkit, or what we call as the Blink toolkit. Okay. Now you can step into functions, you can step out of functions, you can pause on unhandled exceptions. So if you are not a WebStorm user, any WebStorm users here? Okay, just one. So for the rest of the crowd, use this. Okay, you don't actually, one of the key difficulties in Node is the IDE support is very, very limited. What this lets you do is, even if you wanted to go ahead and change code here, right? Abracadabra. And if you want to save it, you can actually save it from a browser, from a debugging session, right into the server-side code. Dangerous, right? Because you can actually break your logic in a runtime production code, but these kind of utilities are very useful when you are in your development lifecycle process. This itself is being called as live edit, okay? So let's go forward and let's see where our story is at. All right, errors. Let's keep this interactive. How many guys have successfully done an error tracing in Node.js or in JavaScript? Okay, and I guess some of you might have used promises or domains or, right? Okay, so Node.js as such is classic asynchronous code, right? And you might have declared functions, anonymous functions, you name it. And there's no thread local type of context like you have in Java. So it's almost next to impossible to clearly stitch together a transaction trace or rather an error trace. So what we are doing with the library, a core library called as zones, is if you zonify your application, essentially it's a required statement. What zones does, it actually creates an IO loop around your execution stream. So every event, be it a read operation, a callback, a DB write, a DB out, each of those logs an event into the zone itself. And when you exit the scope of the zone has a gating mechanism. So you can monitor the resources consumed within a zone. And once you exit the zone, you can roll back resources as well as you can roll back exceptions. So what this lets you do is your Node.js application will not crash anymore. But this also lets you stitch together what is a proper error stack trace. Now, somebody might ask a question, how about, subzones, right? Or I'm going like, what is the scope of this wrapper? The scope of the wrapper, it actually can be nested. As long as you are in the context of a zone, you should be able to stitch this together. So you should check out this project. This is an open source repo. I think there's nothing like this that exists in the Node ecosystem. This will drastically help you do proper error tracing in Node. Okay? Cool. Profiling. So one of the key things that I'm trying to create and see how mature is my DevOps toolchain, right? So what we did with Strong Loop is we created a CPU profiler. So Ben Nudis, who is our co-founder, he also maintains the node profiler sitting on top of V8. So we actually wrote a functionality which lets you stop and start and collect a CPU profile. And anybody here who is not familiar with Chrome DevTools or doesn't know JavaScript console? I guess everybody does. So what you can do is that CPU proc file, you can actually load it within your JavaScript console. It automatically breaks down how much time you're spending in each of the calls, as well as gives you the entire call stack. So if I'm making a sequence of calls, I'm trying to stitch all the calls together in a profile, I can get the net of the CPU cycle time spent in the top level call, which is called total, and then I can selectively break them down into one by each of those functions, which could be a set of anonymous functions, execution stacks, callbacks, how much is the CPU cycle time on each of them. So what I'm trying to really solve here is try to see where is my CPU bottleneck, okay? So let's move on. Now, there can be a fancy way of visualizing it. This is the same Chrome DevTools visual of it, but you can actually plot it as a chart and send a report out of this, okay? Now, how about the fancy chart for your boss? Because if you send him this, he'll probably never get back to you. So you can actually create fancy charts out of this using a lot of Angular code. We have a hosted solution where we call this a bacon donut diagram. Essentially, you can look at your entire call stacks as well as your function calls up to memory line of code, as well as how much time you are spending on there, right? So, does Node.js have memory leaks? Who thinks here that Node.js has memory leaks? Not sure, right? Okay, a few of them. Well, so memory leaks in Node.js code are fairly rare. There was a big one that happened in weekend, and that actually got fixed. And that problem hit Walmart Labs when they were trying to scale up Node.js for their m-commerce applications, right? So a variety of companies contributed. We were there, Joint was there. We tried to nail down where the leak was. The leak was actually in the V8 profiler itself. So we had to go and change Node core. But when you are writing JavaScript on top of V8, how can you ensure that your application doesn't have a memory leak, right? Forget Node core. So what we have done is, just like the maturity of a Java toolchain 10, 15 years back, there were utilities to create thread dumps. There were utilities to create heap dumps. We have created a module called as heap dump, so you can actually go and do npm install heap dump, and lets you take effective heap snapshots. Now you can put a strategy around designing heap snapshots. You can take it on a timer basis. Say, hey, every 60 seconds take a heap snapshot. Or you could say every time I reach a threshold, maybe memory went about 200 megs, take a heap snapshot. Now those snapshots ideally can be read in the same Chrome DevTools visualizer that you have. Okay. Now if you really have to, and you can look here, what are the key important things here to keep in mind? Object counts. So during multiple garbage collection cycles, when you're trying to effectively look at memory leaks, you need to watch object counts. How many instances of the objects are created? You also need to look at the shallow sizes and the retainer sizes, because the retainers essentially maintain the garbage collection routes, or what we call as GC routes. Those will tell you which objects are holding back memory. And and the way you determine that is your object counts, or the instance counts of those objects will not clear up as you go over multiple garbage collection cycles. So this is a very effective tool. We'll let you go down to a class level and the method level. Now another fancy chart for your bosses. If you want to plot this out, you can grab those profile metrics. We call it object tracking, and I'll give you a quick run through of all of these, how to run it. Okay, so we are getting there. So let's see, we have great dev tools. Yeah, but what about the 3 a.m. problem, right? Is it production ready? All the developers have been looking at these tools. So first thing you need is 24/7 monitoring, right? And you might have used some products, traditional APM products. New Relics, the app dynamics, the introscopes, the diner traces, and HPs and all. They go across very wide, right? What you needed was a laser focus on Node.js as a core platform itself. So essentially what we did was we wrote an agent, we call it the strong agent, and we started instrumenting key metrics like event loops. The event loops actually help you determine how much concurrency is your node application going to handle. If the event loops get slow, event loop is a postmaster process. There is no threading mode. Event loop is run single-threaded. It watches for every request that comes in, handles back a C++ pointer called as callback, and then watches for the response to the callback, right? So it's continuously running and scanning your system. Now on the back end, for I/O operations or for DB operations, it will use multiple threads, right? Those are system threads or operating system threads rather. But if your event loop starts to choke, as a after effect of that, you will see response time shoot up, regardless or no matter how fast your backend is, right? So the event, looking at the event loop is probably the most important metric in terms of monitoring the health of your system. Okay. Okay, so we did some extra stuff in here. We piped our agent to a stats-D protocol so that you can split this metrics into other systems, APM systems. If you are using open source tools like Graphite, you can put this into Graphite, Datadog, Zabbix. If you use tools like Splunk, you can send the metrics into Splunk. If you just use a log reader, you can send these metrics into a log reader as well. Okay. But all of these tooling or any monitoring techniques always had one bottleneck. Everybody used a technique called as monkey patching in JavaScript, which was essentially method replacement. So you looked at a JavaScript function and you said that for Express.js, I want to look at HTTP calls, I want to look at SQL calls, I want to look at connect calls or socket calls, and I only instrument certain packages, right? And when I do that, what I end up doing is I do method replacement. So I pick up a method, I replace that method with a timer and get the data back, okay? What we have done recently, and this is probably revolutionary in Node, this does not exist, okay? It's called dynamic instrumentation. So on a runtime production process, you can create a JSON file and you can apply a hot patch. And in that JSON file, you can specify which line numbers you want to get performance metrics out of. So this might be a declared function or even within a function. You are trying to do a try-catch block within a function, and from a piece of logic, you just want to get timer-based data or performance data, you can generate your own APM metrics out of this. Right? So hugely popular. So you can do custom logic, you can do rollback, but I think the main takeaway here is line-level instrumentation and live editing of the instrumentation itself. Okay, so look, he got monitoring, good, but how do you promote? Show me some scaling. So I'm going to show you another set of good open source tools in terms of scaling a Node.js application. So traditionally, if you look at the single server world, right, you have Node.js is single threaded, so it logically binds to one CPU core. And when you try to scale, people have used techniques like standing up individual processes, one on each core, and then putting an Nginx load balancer or an HA proxy load balancer in front. Node itself at the core level has something called as cluster manager built in, right? In V10, cluster manager did not have proper round robin load balancing. But V11, V12, it actually has round robin load balancing built in. So what it lets you do is the controller can spin up as many number of Node.js processes on demand. And every process is a worker process which is bound to a master. And the master gets all the load, does the load distribution using file descriptors, and you can scale up, scale down on demand, as well as ensure 100% high availability. If you use tools like PM2 earlier, these were all created off the ecosystem. Cluster management is built into Node itself, okay? So you should be able to make full utilization of this. If you are sharing state between processes, you can use Redis type stores to manage transaction state. Now let's talk about getting a little bit more distributed and scaled. So essentially this also does not exist today. You can call this as a supercluster. What we are trying to do is when you try to build APIs in Node.js, every API could be a set of services or microservices. And when you deploy these services across hosts, you might want to manage them as a single cluster across distributed machines. Now, how do you do that? So what we have designed is what we are calling it as a mesh. We have a concept of a service container, which is essentially a Docker image. And a Docker image is self-contained with an Nginx load balancer in front, a master worker configuration, and an automatic boot-up configuration. Agent for monitoring, as well as a Redis type store for sharing state. And what it does is anytime an application is provisioned or deployed, you actually split this into API microservices. Each microservice is self-contained within a Docker image. And the state of that service, all the processes it's running on, it's stored and consistently persisted into a Redis type data store. Now, when your actual traffic comes in at runtime through traditional gateways, right? You might be using a variety of gateways, Data Power, Layer 7, Apogee, there are a bunch of gateways out there, right? So these, we actually put out an open source API gateway as well, on pure Node.js API gateway, which can refer to this state store and make routing decisions based on that logic. Okay. So if you look at, hey, what are you guys trying to create here? We are trying to create a web logic for Node. Not that you'll be deploying apps in Node, you'll be deploying APIs in Node, right? So there are other pieces around log aggregation, but the net was the boss got convinced, right? So he said, hey, I'm a Node hipster now. So, but he's not the only one, right? These are the guys which were in the first wave of companies who went and have put highly scalable environments in Node.js. There's the second or the third wave of big companies who are rewriting their API stacks, or rather integrating their API stacks to work for omni-channel mobile, along with Angular projects on the front end, looking at non-structured databases at the back end as well. Okay. So essentially, that's how you win the Node.js story in your enterprise. Okay, but let me quickly go and show you some live code. Okay, so we showed you debug. Let me try and scale an application using cluster management, general node cluster management. So let me make sure there's no application running here. Okay, there are a bunch of applications. So node. Okay, so I'm going to do SLC run -- Normally when you run an application, you say node app.js, right? And then you put it in the background in some non-graceful manner. But anyways, let's say I have a host here which has 8 CPU cores and I want to scale this application up. And I'm going to say -- cluster, and let's start this application on 3 processes. Now, if I open up another window here, and do SLC run control status, you can actually see there's a master process which is called as a supervisor, and it actually has 3 child processes. It automatically is routing traffic to each of those 3 processes. You don't have to hit any individual process one by one. Okay. Now let's say we got some traffic based on the monitoring data we are collecting, and we need to scale this. All you need to do is you can say SLC run control, set size. Let's scale this up to 7 processes. If I now check, the interesting fact is the master remained the same. The first 3 worker processes remains the same if you can validate the process IDs here. And you simply added 4 new processes to the cluster without actually restarting the application. So you hot deployed scale, right? Now let's try to do something funky here. I'm going to put some bad code and see what behavior we find out. So let's say connect JS, right? This doesn't exist. This is a bad module. Now, if I try to restart this application, okay, and let's see what the status is here. Okay, now you see that the master process is the same, and you have 80 through 91 retained, but you lost 78 and 79. Okay, let's check it again. Still the same. Still the same. Right? So it's always around the 5 number. So what's really happening here? Any clues? Pardon? Yeah, so what it does is Node.js, when you kill a process, right, it always tries to restart that process over and over again. But this time, when you push the restart, it identified that the application crashed. If you check the logs, it will tell you that this module does not exist. Okay. However, on the first process restart, once it found that out, it tried to say, okay, maybe this is an aberration. So let's go and try to restart the second process. And the second process crashed as well. It tries to isolate the fault and not spread out the restart to the rest of the cluster till that application can be fixed. Okay. So now what you are seeing is, think about it. If you are running a 16 process box, right, you only lost 2 processes. You still are operating at 14 processes. Now let me try to go ahead and fix this guy. Let me try to make this as it was, which is the correct module. Pardon? Yes. It will, well, so if you restart that, if you don't fix it, right, you try to start up another process, it will always have a fresh context. So it will never actually start up. It will complain that, hey, you have an error in your application. But now if I actually check the status, you can see without restarting, it applied a hot fix, right? Yeah, go ahead, please. Yeah, so the errors actually would be piped out to the logging as well. Yeah, so traditionally what we are doing is across all these clusters, let me show you. We are logging, aggregating the logs for every process. So there is a log aggregator built in that we put into the controller, and which you can just use. And if you look at the supervisor, okay, let's look at it. Yeah, so you can actually pipe this out when you turn on logging. You can pipe it out, it will be logged to a process called a supervisor.log, which will show you all the error messages that, hey, this guy is not booting up, right? But if I say run CTL again, there's one thing totally interesting that happened. Earlier, my application ranges was 13, 8, 9, 80 through 91, right? Now, I have gone all the way from 754. So what happened here at the hood? What happened is it found that this application got fixed. I did not push a restart, it automatically did it. And then it went ahead and restarted the other 5 processes in the cluster. However, the first 2 processes in the meanwhile almost did 100 restart attempts in the time that we were speaking. Okay. So when we finally found that this is a healthy cluster, then it pushed out the rest of the department to all the ones. So now they are all in sync. So these are techniques that you can use when you are doing, production type deploys. You need to roll back, do rolling restarts, all those kind of things, right? Okay, so I'm going to show you a couple more here. I'm going to show you how you get dynamic instrumentation, right? That might be.
I have a question for you.
Yes, go ahead.
So while it's doing that, what kind of transactions are
Yes. And you also have a soft start and a soft stop option. But generally what happens, till the cluster makes sure, the cluster manager makes sure that it's a healthy code, it will keep those routine as is, keep routing traffic. And once it says, okay, now the code was fixed, it will boot up the others, but then rolling restart the other ones one by one. So your availability is always 100% there. Okay, so let's go ahead and stop this filler. Okay, and let's go ahead and I'm going to show you a couple examples. Actually, okay, so now if I'm doing Let me see you some CPU profiling here. So I have two worker processes, one master process. And what I can do is I can just do run control, CPU start, and just pass it the worker process ID, or just the ID itself. And then I can just say stop. So what it did, under the code, was it created a CPU proc file. Now if I analyze the CPU proc file, I can open up a Chrome Dev browser. We actually built a studio, which we are also developing for API composition. So I've just loaded there for visualization purposes. And essentially, this is the same JavaScript console that you are used to. Switch here. If you look at the CPU profile, this visual is the heavy bottom up. You can look at the chart-based distribution. This doesn't have too much, but you can also look at there's no tracking going on at all. So you can look here that by default, the program itself, the root program itself, is taking 99.8%. There is no program execution going on. So now let me load an interesting profile, which might make this analysis a bit simpler. We have an application. Let's look at this one. This is a really interesting. So if you look at this, I have the root domain consuming the idle time is 84.62%. But then I can see that this section of the code, there's a walker, there's an update state, split path. Each of them, this walker itself is taking about 1.6 seconds of the CPU time. Now, in the end, your CPU will be sitting idle 84%. So these will be more. But if you start looking and walking down this stack, you can see it has multiple sequence threads or execution threads. And each of those, if you look down, let's see which is the biggest consumer here. This one, data, object, find, ACL check, model object. So essentially you are going to the entire call stack. From a production CPU profile, you look at a bunch of anonymous calls, and you can keep going till the very last endpoint. But think about this, right? This is all asynchronous. You have one thread here, one request stream here, one request stream here, one request stream here. Your first request stream, you are getting the entire call stack, and you can break it down into individually how much CPU cycle time you are spending on each of those methods, regardless of whether they're anonymous methods or named methods, as well as you can look at the entire request stream at the topmost layer. So this is way beyond the capacity of traditional transaction management. You actually have to get down into the guts of using the profiler tools. Make sense? If I want a fancy chart here, I can break it down and go down here. Let's expand these. And let's say, okay, cool. I have some hotspots here. Keep going, keep going. Oh wow. I start seeing all my calls. And I can also see how much time I'm spending on each of those calls. If you just look at the block in white here, you can actually see how much time you are spending, what is the URL, what is the aggregated time, what is the actual function name which is generating that CPU profile. Okay. Cool. So let me go ahead. There are a bunch of things you can do with heap dump analysis as well. But I wanted to show you dynamic instrumentation because I think that's one of the biggest bag features that is coming out in Node. So let me. Okay. Let's make sure there is no application. So I'm going to cheat here a little bit. I have my back end. I'm just going to change this port so that I can throw some load at it. I have a pre-scripted load file. Okay, so I ran an application, and what I'm going to do is, additionally, I also have a statsd installation there. What statsd does for me is when you say dash dash metrics, SLC run dash dash metrics, I have moved this up to a statsd server, which is another open source SVM module. Statsd acts as a bridge of those metrics. If you want to send these metrics to a console, to a metric visualization system like Graphite, or to Splunk, or maybe to a log, right? So essentially, all these metrics, as I started printing them out, you could see that I am getting regular metrics like event loops, tiers, CPU, garbage collection, heap, and all of those, right? Now, if you wanted to, on the fly, let's go this example. I'm going to show you a patch file here. Let's go. And the patches are different as compared to those versions. So you can create your own patch file for your application. But this one is essentially looking at HTTP requests. And you have two types of metrics to play around with. One are timers and one are counts. Right? So you can say, oh, I have this custom piece of logic and I want to increment a counter whenever I hit this logic and decrement otherwise. Or maybe I want to just start a timer and stop a timer anywhere I wish in my code. Can be within a function call. All you need to do is specify the line numbers. Okay, so this will be your generated batch file. Now what you can do is, let's see the running state here. Okay, so I can say SLC run control patch, and I'm going to patch the process, which is this worker. I'm going to apply patch the JSON file. Let's see, I said okay, and I have a script. I'm going to throw some load at it. So now, if I look at these, are you seeing a set of scrolling custom metrics getting generated? And these are all your SQL call metrics, these could be core metrics in terms of HTTP request counts, objects that you want to track, right? Now, this is a really state. How do I visualize this? So what I did was, I'm going to show you an example of Graphite. You don't have to use Graphite, you can use any of yours, right? So when I start generating these metrics, Graphite is an open source, although it's not known, you shouldn't say it's Python. But essentially what it does, it sends you all these gauge metrics. You also have the sample metrics where you can look into each processor. So I have about 8 processors. For each of those processors, I can get, if you're looking at metrics, like, okay, CPU total, user, garbage collection, heap. But more interestingly, what you're really looking for are objects. So all the object types that your application is running, this could be arrays, this could be, you can actually look at sizes for all those arrays. Oh, I'm running buffers, I'm running TCP connections, I'm running parsers, each of those, you can start plotting them as your own custom metrics, right? So think about it, right? You have become your own APM provider without actually paying for this service to anyone. Okay. But essentially, these kind of on-premises deep instrumentation stack are needed for you to get to that next level of maturity with Java or .NET and other platforms have already reached. So I think I'm going to probably end on that. With that note, you should check out our website. We can go, most of our utilities are 100% open source. The controller is open source. And you can actually contribute to these projects as well to make the ecosystem